continuity correction. Now this just comes up every so often, but it's worth keeping in mind. Every so often, one of the continuous distributions, and the three we've looked at and cover in this course are these three: uniform, triangular, or normal, are used to fit a counting or a rounded measurement situation. Now, we need to allow for the fact, if we've got a continuous scale, that if we say 46, we really mean anything that would be rounded to 46. So, roughly speaking, everything from 45.5 to 46.5 would be called 46 if we were rounding to the nearest whole number. So, e.g., if the number of students turn up to a tutorial is approximately normally distributed, okay, with the mean of 54 and a standard deviation of 3. Now that's fine, but the number of students is not continuous, that is discrete. So you can have 53, you can have 55 or 57, but not 52.8. So the question would be something like, what is the probability of 50 or more students turning up? So if x stands for the distribution of the number arriving, probability of x is greater than 50. We adjust this slightly. Before we go to a calculator, on the calculator nothing changes. All the change is actually just here. Everything else is completely regular. Well, we say, well, the probability something is greater than or equal to 50. We adjust this, and usually we're making the area larger. We say, oh, well, actually, if something 49.5 gets rounded to 50, so on our normal distribution scale along the bottom, we can't just start at 50 because we're missing out a half. So we'll say the probability that x is greater than or equal to 49.5. Now, all we do is allow for that rounding 0.5 barrier either side, usually to enlarge the area. We only do it in a situation where there's counting or rounded measurements, but we're using this continuous distribution. If that's the case, we do that. We do that before we go to the calculator, and then we get to there, and we work out the probability just as we normally would with the normal continuous distribution. Okay, right.